Good day. This video is to accompany lesson 6-5. In this lesson, the essential question is how are properties of logarithms used to simplify expressions and solve logarithmic equations? You'll remember that logarithms are very related to exponents. In fact, b to the x power equals y, and if we want to solve for that exponent, we can rewrite it in logarithmic form. Log base b of y equals x. And so it follows that the properties of logarithms are very related to the properties of exponents. In the Explore and Reason, you are taking a look at the graph of y equals log of x. Remember that this is a common logarithm with a base of 10, but the first thing you've got to do is just put in the values into your table. So you take 5 and it corresponds to 0.699, and you'll put in 15 and put it right down here. What you're looking at is when you are adding, you'll just have to play around with those numbers a little bit, but you should see a pattern that you're like, that's interesting. And it will lead right to the product property of logarithms, that when we multiply m times n, that's the same as taking the value of log base b of m plus log base b of n. And so in our first example, we go through proving the product property. Now if you look at just this example, you won't be able to fully grasp what's going on here. And so I would really encourage you to write it out. Although you don't have enough space in your companion, it's a really good idea to write out what's going on here, because they're telling you, okay, well, x is going to represent log base b of m. Y is going to represent log base b of n. And so when you're thinking about this, you'll rewrite those then that b raised to the x power is m and b raised to the y power is n. And so those are things that we know to begin with. So if let me clear the annotations here. If we say, and we start to take and multiply b to the x power times b to the y power, what we would have is our m times our n. All right, so we can follow that. Thinking back to our product property of exponents, we're multiplying like bases so we can add the exponents. Now, all they've done in the right-hand side is just gotten rid of the multiplication symbol. When we rewrite that in logarithmic form, we pull our x here and we have a log base b and we have our argument of mn. Now our last step, they're filling in here. We remember from above that x equals the log base b of m, and so we replace x with that. When we think about y, here it is, and we're going to replace y with log base b of n. So it turns out, just as we saw in the Explore and Reason, that when we are adding two logarithms with the same base, we end up multiplying the argument, so m times n. Now, the try it feels like a jump for some of you for sure, but what we're going to do is very similar. And so I know you can see it, and I know you can see it on your computer, but if I can hide it, I will. We're going to start off with the same established ideas, that x is going to equal log base b of m and y is going to equal log base b of n. Okay, so then rewriting that, we have b raised to the x power equals m and b raised to the y power equals n. So the quotient property, quotient remember means divide, we're going to take b of x and divide by I'm sorry, I said that incorrectly. B raised to the x divided by b raised to the y. So that's going to equal m divided by n. When we think about our quotient property for exponents, if we have the same base, we can subtract the exponents. And so in this step, we're subtracting the exponents because of our exponent properties. That still equals m over n. Now rewriting this in logarithmic form, we have log base b, because our base is going to drop right over here. And we have m divided by n, that's our argument, so that's coming right here, and our exponent comes out, and so we can solve for it. Now, again, in this step, just like in the last part, we are replacing our x with log base b of m, and our y with log base b of n.